Welcome to Maths and Science by IITian channel. Today in this lecture for NEET and JEE Physics, JEE Mains and NEET Physics, we will be taking up mechanics. Under mechanics, till now we have cleared rotational motion 12 lectures. In this lecture, I will be taking up radius of gyration. It's very important concept for finding the moment of inertia, because the crux of the matter for finding or solving many problems in rigid body motion or rotational motion is about finding the moment of inertia. We have seen previously how to find the moment of inertia. Now we will be talking about the radius of gyration, from which we can say that moment of inertia is equal to mass moment of inertia it is, because mass is involved. I is equal to mk square, where k is equal to radius of gyration. When you know the radius of gyration of a rigid body, then squaring it and multiplying with the mass of the rigid body, we will get the moment of inertia. This has a lot of engineering applications, physical applications, even including in medicine. When we have robotics or any rigid body motion in medical instruments, then when you know the radius of gyration, we can easily find out the moment of inertia. From moment of inertia, the rotational motion and equations of motion can be written. Once equations of motion are known, then that particular instrument, how it behaves, how to apply it in medicine, engineering, or in any physical applications, we will be able to know. Hence, from the NEET point of view, JEE Mains point of view, this is one of the most important topics to be understood, radius of gyration. Let us go into the details. For example, a rigid body is there and the x and y axis are like this. Axis of rotation is this is the origin. Through origin, y axis is the axis of rotation. Let us say omega. Now we have seen m1, m2, m3. There are infinite number of particles within the rigid body, and when you take out the position vectors of m1, m2 and m3, the distances may be r1, r2, r3. There are infinite. We are not telling that it is confined only to m1, m2, m3. There are on the negative side of the origin also, this side also, this side also. Numerous numbers are there, like m1, mn. And this is Rn. Now, what is the RCM? Total mass into RCM is equal to sum of, this formula we have already discussed. From n1 to infinity, sum of the particles, product mi ri. In this, If we take only linear values, what happens? Positive value will get cancelled with the negative value. For all the values, what I have to do? For all the values, I have to sum the absolute values so that they will not get cancelled and the correct moment of the correct RCM will be known to us. Once RCM is known to us, please try to understand. This is very important concept. Sigma n is equal to 1 to infinity mi Ri divided by total mass. Total mass is nothing but n is equal to 1 to infinity mi Ri by sigma mi. N is equal to 1 to infinity. This is the formula for RCM which we have discussed in the previous classes. Please refer to my earlier classes for this. Now, if I don't put the absolute values, what happens? Positive, negative will get cancelled, and a type of this type, some disk is there, and this is the origin, center, and about the origin I am taking, it is the axis of rotation. Please try to understand this, very important concept. About this axis of rotation, I am taking, here it is M1, M2, this is M3, M4, 1, 2, 3, 4. By symmetry, maybe infinite, no problem. By symmetry, negative values get cancelled with the positive values, and sigma mi Ri is going to become 0. If you do not use absolute values, sigma n is equal to 1 to infinity mi Ri tends to 0, because positive and negative values get cancelled in addition. Hence, we are required to take, we should take absolute values. To avoid all these complications, for example, please listen. Plus 1 whole square is equal to how much? Plus 1. Minus 1 whole square is equal to how much? Plus 1. That means plus Ri whole square is equal to plus Ri square. Minus Ri whole square is equal to plus Ri square. That means when it is squared, all the values get, when a value is squared, the sum of squares will add up. Sum of squares will add up, they will not get cancelled, because minus Ra whole square is equal to plus Ra whole square, plus Ra whole square is equal to plus Ra square, so that they will add up only, they will not get cancelled. Hence the concept of squaring is adopted in physics. So that instead of taking the Ri, sigma mi Ri by total m, will take out When this is squared up, you know very well, moment of inertia is equal to mr square. This much you know, we have discussed already. Mass moment of inertia, it is called as mass moment of inertia. There is another moment of inertia also called as a second area of moment of inertia. I is equal to r to the power of 4, where it is second moment of area usually being applied in engineering applications, or moment of inertia, it is area moment of inertia, that is equal to r square into r square. Now we are talking about only mass moment of inertia. Mass moment of inertia is mr square. That is mass into distance square, that is equal to ml square t to the power of 0. Now this mass moment of inertia, where is area moment of inertia? Or second moment of area? R to the power of 4, that is r square into r square, that is L to the power of 4. Whatever in the context that is given in the examination, please, if it is given mass moment of inertia or simply moment of inertia in physics, then you can take mr square. If it is specifically given that second area of second moment of area means, then you have to take L to the power of 4. Now, leaving these two aside, the thing is, why we have adopted r square? The reason being, Ri can be either positive or negative when it is taken in linear sense, and the summation can lead to 0. Whereas Ri square can never be negative and summation will never be negative, will never tend to 0. If there is a mass existing, rigid body is existing, the summation will never lead to 0. That is the concept behind why we have taken the squares. Now, this whatever equation is there, that moment of inertia, instead of writing mr square, we will write it as mk square. Such that k is equal to radius of gyration. Even though if it is convenient for everybody to remember it as mr square, it is always better remember it as mk square and try to find k for the given object. How to find out k value for the given object and given plane, I will explain now. I is equal to mk square, where k is the radius of gyration, where the total mass acting of the total mass. It's you can say it's as good as RCM, but still with a square, so that linearity doesn't allow it to, where linearity allows it to get cancelled, positive negative values, we have to take the absolute values. Rather, to avoid all these complications, we invented a quantity in physics called as radius of gyration, irrespective of the size and shape of the mr square. Whenever we use, we remember circle, we feel it is the radius. To avoid all the complications, all the confusions in physics, a quantity is invented that is called as radius of gyration. That is represented by k. I is equal to mk square. Please remember, I is equal to mk square. I is equal to mk square. Forget about I is equal to mr square. K has the units of length. K has the units of length. M to the power of 0, L to the power of 1, T to the power of 0. Radius of gyration. Very, very, very important concept. I is equal to mk square. Forget about this, all this till now, whatever you have learnt, mr square and all those things. Now, from this, what you are going to say? K square is equal to I by m. Do you agree? Then, what is the value of k? If you know the moment of inertia of a body and mass of the body, then you can easily find out the radius of gyration. K is equal to I by m square root of I by m. That means K is equal to square root of I by m, which is in meters, in SI units, or L is the dimension of it. Now, the radius of gyration, because this type of question is given in 2025 NEET. I may not be directly taking the NEET example because I want you to solve the NEET question. I will give the concept. There are many questions asked in JEE Mains also on the radius of gyration. Please try to learn physics on the basis of radius of gyration instead of mr square. I is equal to mk square. Now, we have checked the moment of inertia of various shapes like a thin rod. Let us say first one, thin rod, about rotating about its center, rotation about its center. It's rotating about its center. The center is origin. A thin rod. When it is rotating about its center, then what will be its moment of inertia? This is z axis perpendicular to xy. What is its moment of inertia about center? Iz is equal to one by 12 m into, let us say, first draw the thin rod. This is the thin rod. This total distance, let us say, is d. This is plus d by 2, this is minus d by 2. When we take the linear values, what happens? Plus d by 2 and minus d by 2, these values mi, ri, they will get cancelled. We have to take the absolute values. Please remember that. M into d square. Now, what is the value of radius of gyration for this? Square root of I by m. That is equal to square. Mass is not going to change. Please remember. When you are calculating the moment of this radius of gyration, mass is not going to change. What is the Iz value? 1 by 12 into md square whole divided by m. That is equal to square root of d square by 12. That is equal to d by 2 into root 3. Therefore, radius of a gyration of a thin rod about rotating about center is equal to d by 2 root 3. Did you understand? Similarly, you do it for other shapes, for a hoop, for a solid disc, for a hoop. Once you start doing for all the shapes, then you will confidently answer the questions given in the examination. This is what is expected of from the aspirants of NEET. For example, there are 1 or 2 questions on radius of gyration from NEET physics examination and also in JEE Mains. Why don't you try to locate the homework for you? Locate the radius of gyration from NEET physics or JEE physics radius of gyration questions and try to solve them on your own with the above concept. Then if you face any problem, please put your problem in the comments, for which link is there in the description of my video, this video. In 2024 NEET 2024 regarding a solid sphere, using a solid sphere, radius of gyration question asked. Try to solve it. It's a very simple question. Try to solve it. By using the concepts I have explained, you can very easily solve this problem First you have to find out the moment of inertia. That moment of inertia of a body, you know, m is the mass. Moment of inertia of a solid sphere is how much? For a solid sphere, moment of inertia is equal to I is equal to 2 by 5 mk square, then k is equal to square root of I by m, that is equal to square root of I is 2 by 5 m 2 by 5 mr square divided by m, that is equal to where square root of 2 by 5 into r, where r is the radius of the sphere. Like d is the length of the thin rod, here r is equal to radius of the sphere. This is what. What is asked? The radius of gyration solid sphere 5 kg, about 5 meters mass is so and so. Then the value of the x is. That you please see that, try to solve it. You can very easily solve it. If you cannot solve it, please come back to me, because we have to use the, it is about the center. What is asked in the question, you please see. They have asked whatever we had in the previous discussion, that is about the center. You please try to understand. This is the center. About the center I have given you. Now, what they have asked is about x dash, y dash. About k, about x dash and y dash is asked. We have to use the parallel axis theorem to find out the answer. About center, I have given the answer, k is equal to square root of 2 by 5 r. And what about this axis? That you find out, and r is already given. Then from that, you please try to find out what is the value of x. They have given in terms of x. If you are unable to solve it, I will solve it in the next class. Please comment in my video. And it's a very good example. I didn't take it directly because I wanted to explain the concepts to you. And see that you will get the concept clear, and about the parallel axis theorem, about the radius of gyration, and you will be able to solve it. Radius of gyration, I felt I will continue for another lecture. In the next class, I will continue with radius of gyration 2. I will continue this lecture for another lecture, radius of gyration, because it's a very important topic. In the next lecture, I will continue. Best of luck to everybody. If there is a value addition because of this lecture to your knowledge, kindly subscribe to my channel Maths and Science by IITian and kindly share this my channel link to everybody or playlist link to everybody for NEET Physics, NEET and JEE Physics. Best of luck to everybody. Thank you. Thank you for listening to me.